So thank you, Mia, and thank you so much to the Women in AI Ethics for the opportunity to talk to everyone today. I'm really excited to discuss what Dataiku has to offer as a product that's oriented towards democratizing AI and also, rethinking AI. So I think the title of this event is really nicely named because it is about rethinking how we use AI, how we, oversee it, what we do, how do we collaborate with it, and move forward. So I will actually just start the demo. It's a pretty simple demo, and I wanted to leave time afterwards for folks to ask questions. So I'm going to switch over to that. Okay. So what is Dataiku, right? In a nutshell, Dataiku is a collaborative platform to work with people who are both coders and clickers on AI pipelines, whether that means bringing in data and doing just ingestion and cleaning, as well as then, more advanced modeling, deploying it to production and monitoring it once it is in production. And because our tool is so, easy to use and easy to pick up for anyone and really powerful, we also recognize that that comes with a lot of responsibility. And we've built in tools in our product to help our customers be more intentional with their AI. As a software company, it's not our job to tell you what's ethical and what's not ethical, though I, of course, would love to do that, though that's not really our role. And so we want to make sure that no matter what the ethics of an organization is, they're able to align with their intentions around that and stay up to speed with what they're doing. So I'll just kind of overview what is the use case here. So we're going to be looking today at hospital readmissions. And the idea is that we see a lot of hospitals and medical practices deciding to use a sort of model to determine, should this patient that we just got into the hospital, are they likely to be readmitted within 30 days, right? If we don't give them the right care. And if that's the case, what is the care that we're going to give them to make sure that they don't actually get readmitted? Because readmissions are, one, not good for patients and also costly to hospitals. And as we've seen in the news and in sort of the literature, this kind of model can actually be very prone to bias. And as a result, we need to think about those elements of bias, both in the data, in our models, in our monitoring, when building out the pipeline. So I'm going to just go ahead and start us off by looking at the flow. You can see that the flow is where the main work happens, and this is something called a visual recipe that allows us to prepare our data, maybe clean up columns, recategorize things. Then you can see we have some visual machine learning. And we have a number of other visual recipes like grouping, joining. So you can really do your cleaning, blending, aggregation, then do modeling, and then take that modeling out to production. But that's not really the gist of today. Today is really about those special tools that are there to help you stay on track with your intentions. So the first thing you'll see is that within our data, our data sets, you can see a sample of the data, but there's also an opportunity to look at a summary. And we've already built in a GDPR plugin that allows you to actually manage GDPR fields. And I can go ahead and edit this and say, does this have personal data? What was this data used for? How long can we keep it? What's the legal basis for consent? And this can actually be further customized to include more questions around your data. So if, for example, you wanted to implement the data sets for datasheets protocol, you could do that here by customizing this interface. So that's the first part, right? But aside from just knowing where your data came from and how it was built and who built it, we also want to be able to interrogate the data itself. And within our exploration elements, and sorry, just move this thing. Okay, within our exploration tabs, you'll see something called statistics. So statistics allow us to do a variety of univariate, bivariate, and other sort of tests on our data. So you'll see here, I can first just say, based on my data, what is the distribution of race in my data set, and the gender, the age, and what kind of payer code. So as we know in the US, medical care is often tied to how you're going to pay for it. So whether it's Medicaid or private insurance, or in this case, we have a lot of missing data, a lot of unknowns. And then we can also see, all right, what are our main variables of interest? So was the patient readmitted within 30 days or not? That's our outcome of interest. We can see that it's very few percentage of the total patients in the data set were actually readmitted, and that's about 11%, as well as what was their primary diagnosis, different diabetic sort of tests or indicators as well. But let's say as a researcher, a data analyst is coming to the table and they want to understand, okay, what other kinds of biases might exist? So we could look at perhaps a independence test between whether or not someone was readmitted within 30 days and how they paid for their services. And we can see here that these two variables are not independent of one another. Of course, this assumes a lot of underlying distributions are normal and other aspects, but if we just look at it as a big picture to get a sense, we can see that actually when we look at the category of people who were readmitted within 30 days, private insurance payers actually were readmitted at a lower amount than expected according to the distributions in the data. So that gives us a hint that there might be something going on where folks with private insurance, even though on paper they have all of the indicators, the health indicators indicating that they might get readmitted within a certain time frame, they're actually less likely to be so. And that might have something to do with the kind of payment that they're offering. So that's something important for us to keep in mind as we start building our model. I also then decided to break down race and payer code and then split it by gender. So this is a nice way to be able to cut at some of the intersectional aspects of this work. We can see that race and payer code aren't independent for women or men. And we see that there are actually fewer Black women on Medicaid than expected according to the data, but more with an unknown payer code. And so we might think that, again, because there's so many missing data points, this could be skewing our distribution. And then similar within men as well. For African-American patients, we're seeing a far higher skew towards unknown versus known. We don't have that same skew problem to that same extent within white patients. And so we have a better sense of understanding of where our patients are, how our patients are paying when it's a white patient versus not. And that can be problematic because even though doctors and nurses do not really care about that information, even if they don't necessarily care, it can work its way into both their perceptions and into the models themselves that we're going to build downstream. So these are just a few examples of the kinds of bias detection you would do within your data set. There are obviously many more ways you could look for bias, but this serves as a nice starting point. So the next thing I did, just to make it interesting, was clustered the data using k-means. And this cluster actually creates some interesting groupings on like the type of patient coming in. So is it someone coming in with a severe illness, an elective surgery, maybe it's just a regular checkup, diabetic testing, or an acute emergency. And this is a nice way to aggregate our groups out and then apply those groups back to our data set when we start modeling for the actual prediction. This was something just I did for fun. It actually doesn't have much to do with the question of intentional AI, but I guess that's not good because it did it unintentionally. But I did try to do this to showcase how we can actually use the data in multiple ways. Now, once we've done that, I go ahead and I add those cluster labels to my data, and then I can go into the modeling phase. And this is where things get interesting. So if we look at this model, I tried different versions of my model, and I can look and see, okay, how did I want to split the training and test set? What kind of metrics do I care about? How did I handle features? What algorithms did I use? And there's an option for debugging as well, and we'll come back to this. But once I've gone ahead and designed my model, trained it, found the one that I like the most, I can go ahead and check that model for model fairness. So we have something called views here. that lets me know, okay, for a given group, a sensitive group, let's say payer code, because we knew that there was sort of that correlation in payer code. For that payer code and the group being Medicaid, our positive outcome is that they're not readmitted, right? We want to make sure that they're not readmitted. We can compute the four main fairness metrics: demographic parity, equalized odds, equality of opportunity, and predictive rate parity. And in this case, I am going to just focus on equality of opportunity, because it's important to make sure that if someone is a true positive, meaning they're truly not going to get readmitted, we want to catch them. And we want to make sure that we know that they're going to be okay, so that we can focus our attention elsewhere. And when we look at the results, we can actually see that there is quite a disparity between the true positive rate for private insurance holders and Medicaid holders, even against unknown, right? And so for whatever reason, Medicaid patients tend to have a lower true positive rate. And it's significantly lower, it's 14% lower. So of course, the amount of difference that's going to be meaningful will change from use case to use case. And that really depends on your subject matter expertise. But we can look at this immediately and say, okay, there's something up here, there's something wrong. If our Medicaid patients, our model is performing poorly for our Medicaid patients. It's not performing equally across all patients. And that's, I think, quite interesting. We can also look at, other kinds of sensitive attributes. I think what's interesting about this model is that if we look at race and we say that, we know that there's a history of medical bias against Black people in the United States. If we compute this, we actually see that the equality of opportunity between white and Black patients, the difference is minimal, right? It's almost zero, but it's actually much higher. The true positive rate is much higher for the unknown category. And again, the other category, which is like a smaller subset of folks, is also not that much different from the Black and white patients. But it's these sort of unknown observations where we see a much higher true positive rate. I wouldn't read too much into this as like a true model fairness report, only because this is such a few number of observations. But the idea here is to showcase how we can use inbuilt tooling to be able to quickly pick up and look for different biases. Now, we could say that, all right, well, this model looks good. Look, the true positive rate is pretty similar between Black and white patients, but that's not all, right? There's also questions of how did you get this explanation for this patient? So I can actually use our individual explanations to compute the most impactful features for a given record. And instead of using encounter ID, I'll use I have a patient number, yeah. So now we can see that for patient number, for this patient, they had a really low probability of being readmitted. And the things that most influenced that were the number of inpatient visits they've had before this incident, where they were discharged to. Do they get discharged to home or to other self-care? And the number of diagnoses. And we can see other features as well, but we don't have their influence. On the other hand, for patients who are predicted to be readmitted in 30 days, they have number of inpatients, the number of emergency, and as well as their discharge disposition as quite important. And that's pretty common for most of the patients in the top percentages. But here we can see that for this patient, the discharge disposition and inpatient matter, but also their insulin levels went up during their stay. And that actually led them to be readmitted, or led the model to think that they're more likely to be readmitted. So this is very helpful and can be, customized to say, okay, I actually need to see the top 5, and I want to do it with ICE and not Shapley. And you can see how things change there and be able to interrogate your results a little bit easier, as well as be able to go to somebody and say, this is what the model thinks about this record in particular. The other thing that's really great is the interactive scoring. So in the interactive scoring, we can actually go ahead and alter singular elements of our data set and see what happens. How does the model change? And we call this what if analysis. So we know that number of diagnoses is actually very influential in determining if someone's readmitted or not. So here we're looking at it at 8 diagnoses, which is the average. And if I turn that down to 1, I can see how this might change. It's just going to take a second to reevaluate. So now our probability to be readmitted is 40%, and I can add that to my comparator. And now I'm going to run the diagnoses all the way up to 16, so a max number, and I'll add that to the comparator. When I look at that side by side, I can see that changing the number of diagnoses changes the probability by about 3%, right? Which is not huge, but also not small. It's just right in the middle. We can also do other kinds of things like leave this at 8 and choose to understand, does this change for different age groups? And be able to compare that value against other ones. So this is a really powerful feature, and it's nice to be able to add it to this comparator and then actually even export this information so that you can share it out more broadly. So I do want to go back and talk about the question of debugging. So one thing that's really important to Dataiku is that people who have subject matter expertise should have the opportunity to influence the model building, even if they're not data scientists or machine learning engineers. And that can be done in the design tab here, where you can actually add in assertions. And assertions are basically validation questions that we expect that people who are older than 60 should, about 70% of them should end up in the readmitted at 30 days class. And that's just based on what we know of our data, what we know of the literature, or maybe public health experts. And in the same way, maybe our public health experts are saying, well, people who are admitted for an emergency shouldn't actually be readmitted that often. And so we can put in an assertion here that says, okay, if somebody is coming in as an emergency, we don't expect to see more than 15% of them need to be readmitted. And these assertions don't actually change the model, but they do serve as, again, validation points for what you're working on. And we can see here that in this case, our first assertion has failed. We expected, 70% of our older population to actually be readmitted, and that's not the case in this model, or we expected that kind of a prediction. And in the second case, the second assertion, we did meet that criteria because at least 15% of all emergency admits were actually readmitted, but actually was far more than that too. And so you can tweak this as well, and also tweak it to change what pass fail means, right? Maybe it's that you should not be over this amount versus you should be under this amount. And that can be, again, customized. Okay, so those are the main interesting things within the machine learning pipeline. I have 2 more cool things to show, and then I'll turn it over to questions. The thing that happens is this model gets built. Maybe it meets all of our fairness criteria. Maybe it meets some of them, but we're able to say, okay, these are the trade-offs we're going to make, or these are the choices we're making. And this model goes into production. Well, now the model is actually influencing the real world, and it's influencing the new data that's coming in to be scored. And so how do we confirm that our model is no longer drifting or is still in line with the ground reality? So a deployed model can actually be scored for model drift on new data. So you'll see here, we now have a data drift analysis, and this takes just a second to get going. And I'm going to say, okay, for new patients, right? These are new patients that we have not trained our model on. Let me know if my model's still aligned, because I've created parameters and indicators based on distributions within a data set that might no longer be representative of the ground truth. And we can see actually that our data has drifted quite a bit. The ideal data that the model was trained on versus what we are now starting to score on has drifted a lot. And we can see here that the probability density chart based on readmissions is quite different for our test and our input data, test being the data that the model was trained on versus the new unseen data. And again, if you change it to the readmitted class, we also see a similar shift. So this helps us understand, is something drifting, and in this case, what specifically? And that's, in this case, number of inpatients is really problematic because it's very important to the model, the original model, and also quite important to the feature importance of this drift model. The last thing is the idea of model cards. Now that's something that's really common in this area of ethical AI, and Dataiku makes it easy to understand how your model was built using something called, oops, I think I have to click inside of here, I'm sorry. Clicking in here, you can see that I can export model documentation. And this takes like 5 minutes to export because it's a very heavy document. So I did that in advance, and I'll just show it here. You can see that we have sort of an executive summary, when it was built, who built it, what was the methodology used in terms of splitting, in terms of iterations, hyperparameter search, what was any data prep that might have been applied to the data before it was modeled, as well as the problem definition, the ingestion techniques, and all the different elements that were used to build this model. So this is a really nice way to be able to quickly generate that report and be able to share it out more broadly. So I mean, that's really the main features that I wanted to cover. Dataiku is really proud to be democratizing AI in this way, but also recognizing that we need to be very intentional with it and help our customers be intentional with it. So I'll stop sharing and maybe check the chat for any questions. Let's see, I see some in the Q&A. Okay, how does the tool handle PII data or data set where race, gender is not identifiable? Yeah, so that's a great question. The PII data, again, can be handled very similarly using different sort of data security methods. We have a hashing algorithm that you can use to, I guess, like anonymize personal information, and then a number of security protocols around data access and who can see which records. That also is important because we don't host any of the data within our platform. The data is entirely within the operation and responsibility of the organization, and we're just helping act as like a second security layer on top of that. Also, is there a way to compare across different models? Absolutely. Let me quickly share. So we can see here that if I look at my original analysis, I ran a number of models, and these are all of the different types of models I ran. They have all different designs. So if I said, actually, you know what, this one looks right to me, I can always revert back and look at the design of that model. And I could also look at my results in a more tabular format, or even in like a longer model-based format. And these aren't really interesting to look at because I just kept running the same models. But this, you can imagine that when you have lots of different things you're trying out, you can do this very nicely. And let's see, any more questions? So is there a way to correct for the bias in data collection? Oh, sorry, actually, let me just go back really quick. The other part of this question was, how do you identify proxies? So we don't have any specific tools, and I think this kind of gets to the question around data bias correction. We don't offer a specific set of guidelines, like this is what you're going to do to make your data unbiased. This is what you're going to do to find proxies. Dataiku is tool agnostic. That means you can plug it into any database, data lake, data warehouse. You can use any sort of backend you have cooked up, H2O, Hadoop, Spark, SQL. And in the same way, we are sort of ethical AI, fair ML agnostic. We recognize that there are so many different packages out there there are so many different people working on very interesting things, whether it's Microsoft's Fair Learn or IBM or any other number of researchers. And so as a result, we don't actually build that into the product. But what we do give is an opportunity for you to do that and to pull that in. So for example, if you wanted to design a model using Microsoft Fair Learn, you could actually come into the algorithms tab and add a custom Python model. In this case, we're using a scikit-learn algorithm, but this could easily be, ML assertions from Microsoft Learn, or a different kind of data bias correction from the IBM packages. We don't want to be the authority on this because there really is no authority, and we're all kind of figuring this out as we go along. And so that's why we make the product as open as possible so that anyone can come in and start building out the right tool sets for their needs, for their use case, and not getting sort of locked in to any one thing. Oh, I see more questions. Oh boy. Let's see. I think I answered this. Okay, this one is about a podcast. Sure. Yes, on the EDA for proxies, did we answer that then? Yeah, I think like what I like to do for proxies is actually the EDA on the stats tab, looking at not only, oh, this is the wrong data set, but not looking only at the stats test like chi-square, but also using correlation matrix for the numeric values, and then being able to do some fit curve distributions as well. None of my data is ever very good for these fit curves because my data is never normal, but it's still quite interesting to be able to look through it all.